Did you know that a simple grid could unlock hidden relationships in your data? Whether you are spotting trends or validating strategies, a correlation matrix is a great tool for smarter analysis. Let's explore the correlation matrix and how to create one in minutes today on Art+Science. Hey there, I'm Kevin Hartman, Associate Professor at the University of Notre Dame and founder of the Art+Science Analytics Institute, where our mission is to make you a better data analyst. In this video, we will cover everything you need to know to create a correlation matrix, from setting it up with your data to interpreting the results. I will provide a step-by-step walkthrough on building and interpreting a correlation matrix. I'm going to use the XLMiner data analysis tool pack in Google Sheets, but you can easily replicate the same steps in Excel using the data analysis tool pack. A correlation matrix is an incredibly valuable tool for uncovering relationships between variables in your data. The matrix takes the variables in your dataset and displays the correlation coefficient between all of them. You will find a link in the description below to a blog post we wrote on regression that goes deep into the ideas of correlation. But as a quick reminder, correlation coefficients range from +1 to -1. A value of +1 between variables means that they are perfectly positively correlated. When one of those variables grows, the other one does too. A value of -1 means the two variables are perfectly negatively correlated, so that when one of them goes up, the other goes down. Typically, we find correlation between variables somewhere in the middle of those extremes. The strength of the correlation largely depends on the variables and the context of the data, but typically anything over +0.7 or below -0.7 is considered to be strong correlation. A coefficient between 0.7 and 0.3, either on the positive side or negative side, is usually considered moderate correlation, while any coefficients we find between +0.3 and through 0 to -0.3 is really considered weak correlation between those two variables. Whether you're working on sales data, employee metrics, or customer behavior, correlation matrices serve as an important diagnostic tool. They help us analysts identify variables that exhibit some kind of correlated relationship, whether positively or negatively. Also, they can reveal variables that demonstrate no apparent relationship, potentially uncovering significant insights there as well. Correlation matrices are perfect for answering questions like, are there any unexpected relationships in my data? Which variables should I prioritize for deeper analysis? And are my assumptions valid before I dive into more complex models like regression? Today, you'll learn not only how to create a correlation matrix, but also how to interpret the insights it provides. We'll explore what the values in the matrix mean, how to spot strong relationships, and how to use this information to guide your next steps in analysis. Let's dive into the data and get started. So let me show you how easy it is to create a correlation matrix in Google Sheets using the XLMiner toolpack. Now, it's just as easy to create a correlation matrix in Excel using the data analysis toolpack that Excel has. But here's the version of what I want to show you is the version of the Google Sheets toolpack and how simple that is to do. I'm here again in the mock data set I've created for a Google operational health case study. I've got data here on describing 280 some employees, their job title, the org they're in, the team they're in, and then age, some data that I would have collected from their HR profile, as well as the surveys I conduct. The annual Google Guys survey would be a way for me to collect data on the employees, as well as their performance reviews would be another source, right? Again, this is all illustrative data, not real data, but this is the kind of data I would expect a people analytics team to have and analyze about their people, right? And so the first step for me to create this correlation matrix is to install the XLMiner toolpack. That's really simple. I just go under extensions, go to add-ons, get add-ons, Now I'm in effectively the add-on store for Google Sheets, all the plugins that you can add into Google Sheets to expand the capabilities. I'm going to search for XLMiner. There it is. Now mine's already installed. It comes up in the list. If I click on it, it's already installed on my machine. If it's not installed on yours, you just follow the installation prompts to get that tool pack installed. The reason I'm including that tool pack is because a correlation matrix is a really powerful tool that I could build by hand. It would just be super tedious, and it's so easy using the tool pack. If I zoom out, you'll remember that this is the data that we use to create this really fantastic descriptive statistics table. And we use the XLMiner tool pack to do that. Because again, I could have gone in and created all of these different descriptive statistics by hand using the functions in Google Sheets. That would have been super tedious. So let me show you now how easy it is to create a correlation matrix using the tool pack. First thing I need to do is just install the tool pack. And then once I've got it installed, I just need to start it. When it is installed, you'll see it down here under extensions. Click on start, and to the right pops all the different capability now that I have through the tool pack. You'll see here's a descriptive statistics tool that I would have used to create this table. What I want to do is go to the correlation, because the correlation matrix is what I will produce. There's a couple inputs that I need to include. I need to tell Google Sheets where the data is, the input range. I want to tell it, is this data arranged by column or row? Are there labels in the first row? And then I need to tell it where to place the table. So let me demonstrate that now. Input range, if I click in there, I have to be careful not to include any text or alphanumeric data. It blows the table up. So I just have to begin wherever the numbers start, and that starts at age. So I'm going to start there. Shift command over to the right with the right arrow covers my data to the right, and then holding the same keys down and pressing the down key highlights the entire table, all the numbers. Those empty cells are fine. I just can't have the numeric or alphanumeric, which would blow it up. So clicking then, now that I've got my table highlighted, or at least the data that I want to include, click back into the input range and it should update for me. There's the entire table or range of the data that I want to include. It is grouped by columns. I do have labels in my first row. Now I'm going to click into output range to tell it where to place this data, and just being very careful to not put it over any existing data. I'm going to go down, let's say about Q, that looks good, Q19. If I click back into the output range after I've selected that cell, it will update. And now the last thing I have to do is just click OK. And with that click, there's my table. You see how easy that is to produce. And so now I've got this great correlation matrix, which is going to allow me to take a step beyond the descriptive statistics analysis that I was doing. And there's a number of things that I'm going to look for. I'm going to look for correlation that is obvious, just to confirm some of the hypotheses that I might have. I'm going to look for correlations that are not obvious, things that might be surprising to me. And then I'm going to look for places where I would expect to see some correlation that might not exist. That's going to be interesting to me as well. First thing I'm going to do is just zoom into the table so you get a little more better view, close out the tool pack, and then zoom into the correlation matrix. The way this is organized, I have all my labels, all my variables down the rows and across the columns. So how I find what the correlation is between two variables is finding that cell where they meet. The one perfect correlation is indicates the same data, right? This is age is perfectly correlated to age. Yep, because it's the same data. And so I'll, as I said, start to look for things that are somewhat obvious, as well as some things that might not be obvious, and some things where I might expect to see correlation but don't. So let's start with an obvious one. Here's one right here. This is strong positive correlation. Anything over 75, 80% is strong positive correlation. This is correlating people managers to direct reports. I would expect that to be correlated. That says my people managers have direct reports. The fact that this is not perfectly correlated, not a 1, is indicative of the fact that different people managers have different numbers of direct reports. There may also be a people manager who doesn't have any right now. Maybe they're on a transition team. Maybe they're in between roles inside the company. I'm not sure, but this strong positive correlation is exactly what I would expect to see. You're a people manager, you've got direct reports. That's not surprising to me, but it just confirms some of my hypotheses. Some things that might be a little more surprising to me. Well, here's one. So what I see here is a very strong positive correlation between belief in the Google Geist mission and the Google Geist manager score. So what this is saying is that when an employee gives their manager a strong score, then they also have a strong belief in the Google Geist mission. Okay, that's interesting to me. What I might want to tease out there is to what extent does who your manager is determine your belief in the Google mission? I would want to see really low correlation there, maybe. I wouldn't want to see those two connected. I'd want my belief in the Google mission to be independent of who my manager is and whether or not I like them or not like them, think they're doing a good job or not think they're doing a good job. So that's a correlation that might be somewhat surprising to me that I will want to dig in a little deeper. What's another one? Well, here's one. So I see very low positive correlation. Again, anything below 75% is low. Anything between say 50 and 75 is moderate, right? Anything below 50 is really, you're getting into the low. Anything below 25%, that's very, very low positive correlation. So positive or negative. So this is saying that there's not really any correlation there. And what I've found is correlated is whether or not this employee attrited, they left Google in the last 12 months, and whether they were recently promoted in that period as well. So here's what's puzzling to me. I would probably want to see that be very negatively correlated. If I'm promoting you, you stick around. The fact that there is no correlation would almost indicate that the promotions I hand out have very little effect on whether or not you as a Google employee decide to leave the company, which getting those promotion chips, I already know from some of my earlier analysis, is a pretty selective process. I just don't throw those out to everybody. So what I really want to believe is that by promoting you, giving you that kind of support and giving you that kind of confidence that you're going to stay around with Google, right? You're not going to leave after you get promoted. Now this could indicate that you just got promoted at Google. You're a hot commodity and you're just that much more attractive to outside companies, and they are making more of a play for you. These are the things I would need to get into and really understand. But you can just see here from the simple correlations that we are finding that a lot of stories start to take on a little more texture. Certainly beyond what I got from the descriptive statistics. And while not fully answering the questions, they are pointing me down that road and giving me even more bits of information, making the picture even more clear so that I can ultimately make some really informed choices. So that's how we create a correlation matrix. Super easy to do with the XLMiner tool pack, and something that really should be a very important tool in your analysis toolkit. And there you have it, a simple yet powerful way to create and analyze a correlation matrix in Google Sheets using the XLMiner tool pack, a process that could easily be replicated in Excel using the data analysis tool pack. As you have seen, correlation matrices are more than just numbers on a grid. They provide a wealth of insights into the relationships between variables. They can guide you toward more focused analysis and smarter decisions. And remember, while correlation highlights relationships, it doesn't automatically mean causation. Use this tool as a starting point to explore your data and set hypotheses for further analysis. By incorporating correlation matrices into your analytics work, you will uncover new perspectives on your data and set the stage for deeper insights. Thank you so much for watching. If you haven't already, take a moment and subscribe to this channel, like this video, and share it with anyone who you think is interested in data analytics. Every single week, we are bringing new, exciting, and important videos on data analytics to this channel, and we would love to have you there for the journey. Also, be sure to check out the links in the description for this video for additional Art+Science resources, and sign up for our newsletter to get exclusive tips, course updates, and more directly to your inbox. Thanks again for watching, and we'll see you in the next video.